I'm R. Prabha, Assistant Professor in the Department of EC, SNS College of Technology. In this video, we will discuss the topic on antenna impedance measurement. So, antenna impedance, there are two types. One is self-impedance and another one is mutual impedance. If antenna is radiating by itself in an unbounded medium, the self-impedance is also called as the driving point impedance. If there is coupling between the antenna and other sources or obstacles, the driving point impedance is a function of its self-impedance and the mutual impedances of the other sources. The antenna impedance is determined by the formula Z antenna is equal to ZC 1 plus capital gamma by 1 minus capital gamma, or it is equal to ZC 1 plus capital gamma e power j gamma divided by 1 minus capital gamma e power j gamma. And antenna impedance measurement methods involves the frequency. And for example, for radio frequencies below 30 megahertz, that is low frequency, impedance bridge method is employed for antenna impedance measurement. And for frequencies above 1000 megahertz, that is at high frequency, slotted line measurement is almost invariably used. And however, in between these two frequencies, 30 to 1000 megahertz, either method can be used depending upon the applications, convenience and availability of the equipment. So we will see the first method of measuring the impedance measurement for a low frequency, that is below 30 megahertz. In this case, we use a bridge is called Wheatstone bridge, which is shown in the diagram. So Wheatstone bridge is used for measuring unknown impedance. It may be resistance, inductance or capacitance by comparing with known impedance. So this Wheatstone bridge consists of 4 impedances connected in 4 arms, and make of the bridge is as in the diagram. Here Z1, Z2 are the impedances, Z4 is unknown impedance, and variable impedance is Z3. And for antenna input impedance measurement, the antenna input terminals are connected as unknown impedance between the points A and D, which is grounded, so it is suitable for low frequency grounded vertical antenna. For balanced antenna, one should see the points A and D of bridge are balanced with respect to ground. The measurements usually are preceded by calibration. The bridge is balanced with unknown impedance terminal, short circuited or open circuited. Then the short is removed and unknown impedance is inserted, and in the unknown impedance arm between A and D, and the bridge is rebalanced. The unknown impedance is now determined by impedance equation. So thus there are two balance conditions which must be satisfied simultaneously. For magnitude balance, it should have Z1, Z3 is equal to Z2, Z4. And for phase angle balance, angle theta 1 plus theta 3 is equal to angle theta 2 plus theta 4. And finally, the unknown impedance Z4 is calculated as Z4 is equal to Z3 into Z1 by Z2. And the second method is standing wave ratio method or slotted line method, which is useful for impedance measurement at high frequency. So the diagram represents the perspective view of slotted line arrangement, and the standing wave ratio method setup is given in the diagram. We have modulation source at the transmitting side. Next comes the signal source, low pass filter, and the slotted coaxial line. And after slotted coaxial line, antenna and a test is connected. And in the slotted coaxial line, we have a detector, amplifier and an indicator. And a transmission line system terminated in an antenna, if not perfectly matched to this feeding transmission line, then we know the incident and reflected waves are consequently produce a standing wave pattern which will be set up along the transmission line. So a part of the transmission line is replaced by a coaxial slotted line, VSWR or impedance measuring setup. As shown in the diagram, the slotted line arrangement consists of a length of a transmission line with an axial slot along which moves a traveling carriage probe. So the probe projects through the slot, and the voltage measuring device may be, in simplest case, a crystal detector and a micrometer. A signal source may be transmitter or receiver, which is connected to left end, and the right end is connected to the unknown impedance being measured. The standing wave pattern is now obtained by moving the probe along the carriage and observing the resultant variation in the crystal detector output. In fact, this device measures electric field intensity, but since it is proportional to voltage between the conductors, therefore standing wave indicator is assumed to be voltage measuring device. And now the probe in the slotted coaxial cable is moved, and the two consecutive points of Vmax and Vminimum are noted. So the ratio Vmax to Vminimum will give the VSWR, and which gives the input impedance. So the probe is inserted deeply into the axial slot line in order to sample the standing wave pattern. Commercial standing wave detectors, a high or low pass filter is used to avoid harmonics, spurious signal sources and unwanted signals between slotted line and signal source as shown in the block diagram. The modulation source for modulating the signal source with a square or pulse. Now the assessment. What is an antenna impedance? We know it is the two types, self and mutual impedance, under which conditions a Wheatstone bridge is said to be balanced. So we have the balance formula. One is for impedance balance and also the angle balance, that is the phase balance. And the significance of slotted line method, we know it is useful for high frequency measurements, and that is above 1000 megahertz frequency. Thank you.